Hello guys, so this is the video from section 2.4. So section 2.4 mostly focus about parallel and perpendicular lines. Objectives of section 2.4 is understand the definition of parallel lines, understand the definition of perpendicular lines, decide whether two lines are parallel or perpendicular or neither, finding the equation of parallel and perpendicular lines, solving geometric application. Okay. So first we'll focus on definition of parallel lines. So two distinct non-vertical lines in coordinate plane are parallel if and only if they have the same slope. So here you have a situation. We have line 1 and line 2. They will never intersect. They are parallel to each other because the slope of those two straight lines are the same. The definition. So before we move on to definition of perpendicular line, first we're going to solve the first example. Show that the line y equal negative 2 over 3x minus 1 and 4x plus 6y equal 12 are parallel. So what we need to do, we need to show that their slopes are the same. So I'm going to work with line 1 first. Y equal negative 2 over 3x minus 1. This straight line, it's already in a slope-intercept form. So we see that slope of line 1 is negative 2 over 3. Next, let's work with line 2. The equation of line 2 is 4x plus 6y equal 12. So to find the slope of line 2, I'm going to rewrite this equation, which is in general form, rewrite in slope-intercept form. So slope-intercept form, it's y equal mx plus b. So what we need to do, we just need to solve this equation for y. I will subtract 4x from both sides. And we're getting that 6y, it's equal negative 4x plus 12. Divide each by 6. And we're getting y, it's equal negative 4 over 6, which is negative 2 over 3x plus 2. So now this is equation of line 2 in a slope-intercept form. So to get the slope, it's the coefficient in front of x. So slope of line 2, it's negative 2 over 3. Slope of line 1, it's also negative 2 over 3. So we just show that those two straight lines are parallel to each other. So since M1 is the same as M2, the lines are parallel. And you can see right here on the graph, we see the graph of equation 1, the graph of equation 2, we see that they are parallel to each other. They will never intersect. Okay. So let's continue. Next, we'll talk about the definition of parallel lines. Not parallel lines. I don't know why PowerPoint shows parallel lines. The definition of perpendicular lines. So two non-vertical lines in the coordinate plane are perpendicular if and only if their slopes is equal to negative 1. So technically, when we multiply the slopes of two straight lines, we'll end up with negative 1. So what that means about the slopes of two lines? You see the line 1 has a slope a over b. Line 2 has a slope b over a with the negative sign. So two lines will be perpendicular to each other if their slopes are opposites reciprocals. Opposites reciprocals. We see reciprocal of A over B, it's B over A. Opposites means one slope will be positive, excuse me, the other slope will be negative. So we're going to practice. We need to show that two lanes, 3x minus 6y equal negative 12 and 2x plus y equal 4 are perpendiculars. So we have line 1 and line 2. So to show that they are perpendiculars, we're going to show that the product of those two slopes, it's equal negative 1. So we're going to start working with line 1. The equation of the line 3x minus 6y equal negative 12, it's in a standard form. So we want to rewrite this equation in a slope-intercept form. So we're going to solve for y. Let's subtract 3x from both sides. We're getting negative 6y equal negative 3x minus 12. And isolate y. Let's divide each by negative 6. So that will give us y equal 3 over 6, which is 1/2 x plus 2. So this is equation of line 1 in a slope-intercept form. And we can see that the slope is equal 1/2. Always the coefficient of x. I will do exactly the same work with line 2. So line 2 has an equation of 2x plus y equal 4. So I need to find the slope of line 2. I'm going to rewrite in slope-intercept form. So that means let's solve this equation for x. Let's subtract 2x from both sides. We're getting y equal negative 2x plus 4. Okay. So this is equation of line 2 in the slope-intercept form. And this is our slope. M2 equal negative 2. So next, to show that those two straight lines are perpendicular, we need to show that m1 times m2 equal negative 1. So m1 it's 1/2, m2 it's negative 2, and definitely that will give us negative 1, so yes, they are perpendiculars. And also quickly you can see that slope 1 was 1/2 and slope 2 was negative 2, so they are opposite reciprocals. Okay. Next example, the same type of work. We need to decide if two given equation, line 1 and line 2, represents parallel lines, perpendicular, or neither. So let's remember that parallel lines, we will need to show that slope 1 is equal to slope 2. For perpendicular lines, we need to show that m1 times m2 is equal negative 1. And if none of that condition apply, that means two straight lines will be neither, which means they will intersect, but not at 90-degree angle. Okay, so I will do exactly the same type of work like before. We have line 1 and this is line 2. So I'm going to rewrite the equation of line 1 in a slope-intercept form to find the slope. So let's solve for y. We'll subtract 3x from both sides. We're getting negative y equal negative 3x plus 4. And divide each by negative 1. And we're getting that y is equal 3x minus 4. So this is equation of line 1, which means slope 1 is equal 3. Next, I'm going to do the same type of work with line 2. Equation of line 2 is x plus 3y equals 7, I want to convert that equation in a slope-intercept form, which means just isolate y. We're going to subtract x from both sides. We're getting 3y equal negative x plus 7, and divide each by 3. So we have y, it's equal negative 1/3 x plus 7 over 3. And this is equation of line 2. So now I can see that the slope of the second equation, it's negative 1 over 3. Okay. So we're going to start comparing. Definitely m1, it's not equal to m2. So those two straight lines, they are not parallel. Now, so L1 and L2 are not parallel to each other. So now I'm going to check if they are perpendicular. So let's check if m1 times m2 will give you negative 1. So we have 3 times negative 1/3, and we're getting negative 3 over 3, which is negative 1. So yes, they are perpendicular. So those two equations are perpendicular because the product of the slopes is equal to negative 1, and we can quickly notice that 3 reciprocal of 3 it's 1/3, and both slopes have different signs. One slope it's negative, the other it's positive. So they must be perpendicular. Okay, we'll do example B. So here the slope of line 1, this equation it's already in a slope-intercept form. So slope of line 1 is equal 1/2. Hold on. M1 it's equal 1/2. And equation 2, I'm going to rewrite in a slope-intercept form. So let's subtract x from both sides. We're getting 2y it's equal negative x plus 1. Divide each by 2. And we're getting that y it's equal negative 1/2 x plus 1/2. So this is equation of line 2 in a slope-intercept form. And I see that slope 2 is equal negative 1/2. So now we're comparing. Slope 1 and slope 2, they not equal. So those two straight lines, they definitely are not parallel to each other. They also not perpendicular. So M1 is not the same as M2, so not parallel. Now M1 times M2 is not equal to 1, so not perpendicular. Because look, M1 is 1/2 times negative 1/2. We will never, that's definitely not 1. So they not parallel, they not perpendicular, so the answer will be neither. Which means line 1 and line 2, they will intersect, but not at 90-degree angle. So example 4, we continue with parallel and perpendicular lines. And in example 4, we have to find the equation of the line, which is parallel to 2x plus 4y equal 1, that passes through the point 3, negative 5. And we need to write the answer in a point slope form, slope-intercept form, and standard form. Okay. So this is what is given. Original equation. This is line 1. I will put it that way. And we need to find equation of the line which will be parallel to the line 1. So that means we have to create the equation of the line which will have the same slope. Okay. So first what we're going to do, we're going to find the slope of the original equation, which means rewrite in slope-intercept form. Okay, so we're going to solve for y. We have 2x plus 4y equal 1. Subtract 2x from both sides. We're getting 4y equal negative 2x plus 1. Divide each by 4. And we're getting y is equal negative 1/2 plus 1 over 4. Negative 1/2 x. So that means the given equation has a slope equal negative 1/2. Okay. So now we want to build the equation of the line which is parallel to the given line. That means the new equation will have the same slope. Okay, I have space. Okay. So here, since we are looking for the line which is parallel to the original equation, that means that slopes of new equation is also negative 1/2. Okay, so I'm building the equation of the new line which is parallel to the given line. So y will be equal mx plus b. This is slope-intercept form. We already know that the slope has to be the same, so we have negative 1/2 x plus b. Okay, so we have it. Next, what we know about the line which is parallel to the given one, that our new line passes through the point 3, 5. Okay, so this line passes through the point through the point 3, negative 5. So we're going to use the coordinates of the given point to find b. Use the given point to find b. So we're going to substitute. We're going to replace x with 3 and y with negative 5. So substitute x with x coordinate of the given point, which is with 3, and substitute y with the y coordinate of the given point, which is negative 5. So we have our equation of line 2, y equal negative 1/2 plus b. We're going to do the substitution. We're replacing x with 3. And we're going to do the substitution. We're going to replace y with negative 5. Okay. So we have negative 5 equal negative 1 to 1/2 times 3 plus b. We have negative 5 equal negative 3 over 2 plus b. I will add 3 over 2 to both sides. And we're getting that b is equal negative 5 plus 3 over 2. So b is equal negative 5. It's the same as negative 5 over 1. So this is the same as negative 10 over 2 plus 3 over 2. b is equal negative 7 over 2. So now we have it. Line 2, y equal negative 1/2 x plus b. which is minus 7 over 2. So this is the equation of the line, which is parallel to the given line in a slope-intercept form. They also ask you to create the equation in a point-slope form. So now write the equation in a point-slope form. So point-slope form, it's y minus y1 equal m times x minus x1. So of course we're talking about line 2. We know the slope, which is equal negative 1/2, and we have a point, which has coordinates 3, negative 5. So we're going to replace x1 with 3, y1 with negative 5, and m with negative 1/2. So we have y minus y1 equal m, which is negative 1/2, times x minus x1. Simplify, 2 negatives give us plus, so we have y plus 5 equal negative 1/2 x minus 3. So this is equation of line 2 in a point slope form. Okay, and now we're going to leave the solution in a standard form. So now standard form is ax plus by equals c. So technically x and y's are on the left side. So I'm going to use the slope-intercept form to create standard form. So hint, use slope-intercept form to create the standard form. So slope-intercept form was y equal negative 1/2 x minus 7 over 2. So we want to move x and y to the right side. So I will add 1/2 x to both sides. So we're having 1/2 x plus y equal negative 7 over 2. And we don't want to have those fractions. So we can multiply all by 2. So we're going to multiply each term by 2. So we have 2 times 1/2 x plus 2 times y equal negative 7 over 2 times 2. And that nicely simplify. And we're having x plus 2y equal negative 7. And this is standard form. So when you create the standard form, you want to keep your coefficients as integer. So I use the slope-intercept form to create the standard form. Okay. So next type of problem. This is the application. They asking if the given points will create the parallelogram, and if the points from a parallelogram, then they asking if the parallelogram is rhombus. Okay. So let's solve this problem. So first, what I want to do, I want to graph those points so we can have a picture. We can understand better. Right, let me just move here. So we have y, x. The scale it's 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, 1, 2, 3, 4, 5, 6, 7, and negatives. -1, -2, -3, -4, -5, -6, and so on. So the first point is 0, 4. Right here, this is point A. Point B, 3, 0. Point C, 9, 1. So this is B. This is C. And point D, 6, 5. C, and this is D. So we're going to connect them. A, B, D, C, and AD, and BC. So to show that those points, it looks like, yes, they did create the parallelogram. We have two choices. So we have to show that segment AD, it's parallel to the segment BC, or we can show that the segment AB, and also we have to show that segment AB, it's parallel to segment DC. Okay. So in order to do that, I'm just going to find the slope. Okay. So I will just label, I want to find the slope between points A and D, and that will be M1. And then I want to find the slope between points B and C, and that will be M2. And if those slopes are equal, then we know that segment AD and BC are parallel to each other. And later, I will find the slope between points A and B. So that will be slope 3. And then I will find the slope between point D and C, and that will be slope 4. Okay. So one more time. So to show that the figure is the parallelogram, show that M1 equal M2 and M3 equal M4, because we know that the slopes of parallel lines, they are equal. So let's find slope 1. Find M1. So to find slope M1 between 2 points, use A equal 0, 4 and use D equal 6, 5. So we're going to use the slope formula. So M1 will be equal y2 minus y1 divided by x2 minus x1. And we having 5 minus 4 divided by 6 minus 0. We're getting 1 over 6. So now I'm going to find M2. So find M2 and find M2, and we're going to use the point B. Point B has coordinates 3, 0. And we're going to use point C, which has coordinates 9, 1. So we're going to use the slope formula. So slope formula is y2 minus y1 divided by x2 minus x1, in our case, we have 1 minus 0 divided by 9 minus 3, and we got 1 over 6. And look what happened. M1 and M2, they are equal. So we know that the segment AD and BC are parallel to each other. So segment AD, it's parallel to segment BC. So far we're on the correct track to show that this figure represents the parallelogram. Next, what I'm going to do, I'm going to find slope 3 and slope 4. And for this shape to be parallelogram, those slopes has to be equal to each other. So then the segment AB and DC are parallel. Okay. So next, show that segment AB, it's parallel to the segment DC, which means show that those slopes are equal. Okay. So we're going to show that those slopes are equal. We're going to use the slope formula. So I'm going to find M3, and we're going to use point A to find M3. We're going to use point A, which has coordinates 0, 4, and point B. Point B has coordinates 3, 0. So we're going to find the slope, y2 minus y1. So we have 0 minus 4 divided by x2 minus x1, 3 minus 0. And we end up with negative 4 over 3. So this is M3. Now we're going to find M4, and we're going to use points D and C. Point D has coordinates, going back to the picture, 5, 6, 5, 6, 5. Use points D and C. And point C has coordinates 9, 1. And we're going to find the slope between those 2 points. So M is equal y2 minus y1. So we have 1 minus 5 divided by x2 minus x1. 9 minus 6. And we end up with negative 4 over 3. So look what happened. M3 and M4 are equal. So M3 is the same as M4. That means segments. So segment AB, it's parallel to DC. So we just proved that the given shape represents the parallelogram. So ABCD is a parallelogram. So we're done with this part. Okay, we know that. Next, what they want you to do here, they want us to check if this parallelogram represents rhombus. So information about the rhombus, that they diagonals intersect at 90-degree angle. So if this is a rhombus, the diagonals should intersect at 90-degree angle. So in our case, we will need to show that segment DB it's perpendicular to segment AC. And in order to do that, we just need to show that the slope between ABD is opposite reciprocal of the slope of the segment AC. So we're going to find slope M6, M5, and M6. We're going to find those slopes and we have to show that they are the product of the slopes will give us -1. So that means those segments, the diagonals, intersect at 90-degree angle. So I will just continue here. So to show that ABCD is a rhombus, show that the diagonals intersect at 90-degree angles. So show that BD is perpendicular to AC. Show that BD it's perpendicular. This is BD, the shorter diagonal. It's perpendicular to AC, which means show that M5 times M6 equal -1. So the slopes, the product of the slopes is equal -1. So we need to find the slope. So find M5 using point B and point D. So point B has coordinates 3, 0. Point D has coordinates 6, 5. So M5 equal y2 minus y1. So we have 5 minus 0 divided by x2 minus x1, 6 minus 3. And we're getting 5 over 3. Now we have to find M6. Using point A, and point A has coordinates 0, 4, and point C, because that's the coordinates of the longest diagonal, has coordinates 9, 1. So we're going to find M6 by using formula y2 minus y1 divided by x2 minus x1. So we have in y2, y1, x2, x1. So we have 1 minus 4 divided by 9 minus 0. And we have -3 over 0. Wait, over 9. Which will give us -1/3. -1/3. So this is M6. Okay, and I can tell that those diagonals, they don't intersect at 90-degree angle because M5, it's 5 over 3. So for the lines to be perpendicular, the slopes has to be reciprocals with the opposite sign. So reciprocal 5 over 3 should be 3 over 5. So, but definitely not perpendicular. But here we're going to just show that M5 times M6 it's not equal to -1. So M5, it's 5 over 3 times -1 over 3. We're getting -5 over 9 since not equal 1. So not a rhombus. That means those diagonals, they don't intersect at 90-degree angle. So that was the long problem. But like you see, in all those problems, it will be hard to solve that problem without sketching the picture of the parallelogram. But like you see, for all those problems, I was finding the points between. I was finding the slope between given points, and I was just comparing slope. So just to catch up quickly, to show that this the shape A, B, C, D, it's parallelogram, I show that slope 1 and M2 are equal. That means those segments AD and BC are parallel to each other. And then I show that slope M3 and M4 are equal, which represents that segment AB and DC are parallel to each other. And we end up with the correct answer. Yes, this shape represents the parallelogram. Then, in order to show that this shape is a rhombus, I should show that the diagonals intersect at 90-degree angle. Even on my picture, it doesn't show that, but I still have to use the algebra. So I find the slope m5 of the shorter diagonal. Then I find the slope m6 of the longer diagonal. And then I check if they slopes by multiplication, if they will give me -1. And that's end up to not be a true. So when I multiply slope 5 and 6, I didn't get 1. I didn't get -1. Let's just fix that. I didn't get -1. That means that the diagonals are not perpendicular. Okay. So hopefully this video will help you with section 2.4.